Hello my dear students, today I am coming with another video about GC. GC means gas chromatography. This chromatographic technique is also used for the separation of compounds. Here it is mainly used for the separation of volatile compounds. The key word is volatile compound. So for the separation of volatile compounds, we can use this GC or gas chromatographic technique. We all know that the mobile phase used in gas chromatography is gas and the stationary phase can be either solid or liquid. If the stationary phase is a solid, we can call this technique as GSC, means gas solid chromatography. If the stationary phase is a liquid, we can call this technique as GLC, means gas liquid chromatography. In GSC, the stationary phase is solid. Here we can use the stationary phase as either silica or alumina. Whereas in GLC, the stationary phase is liquid. Normally we can use a thin layer of liquid on inert solid support. Then we are moving to the principle of gas chromatography. The principle of gas chromatography involves the differential distribution of components between the mobile phase and the stationary phase. Here I already mentioned that there are two types of gas chromatographic technique, GSC and GLC. In GSC, the principle is adsorption, whereas in GLC, the principle is partition. Partition means the ratio of solubility of components in the mobile phase as well as in the liquid phase. Liquid phase is stationary here. So once again, the principle of GSC is adsorption and the principle of GLC is partition. Then we are moving to the instrumentation of gas chromatography. The instrumentation of gas chromatography involves 5 different components. First one is carrier gas. Second one is sample injection system. Third one is column. Fourth one stationary phase. And fifth one detectors. So first one is carrier gas. Normally used carrier gas in gas chromatography is nitrogen. In the absence of nitrogen, we can also use argon, helium, hydrogen, etc. This carrier gas is flowing through the system, carrying the sample in the vaporized state. Then we can moving to the characteristics of this carrier gas. There are mainly 3 important characteristics are there. First one, it should be chemically inert in nature. Second one, it should have best column performance. And third one, it is suitable for the detectors employed as well as the sample which is to be separated or which is to be analyzed. Okay. So carrier gas, which is nitrogen. In the absence of nitrogen, we can also use helium, argon, hydrogen, etc. Then I mentioned the 3 important characteristics of carrier gas. First one, it should be chemically inert. Second one, it should have best column performance. Third one, it is suitable for the detectors employed as well as the sample which is to be analyzed or separated. Then moving to the second part of GC, it is sample injection system. From the name itself, it indicates that it is actually used for injecting the sample into the system. So this injecting of sample, which can be done with the help of a syringe, which is covered by a silicon rubber diaphragm. Why we can use the silicon rubber? Because it is highly thermal stable in nature. That means before entering into the column, the sample must be converted into the vaporized state. So heating is required. So a thermally stable silicon rubber covering can be used along with the syringe to inject the sample into the system. Okay. Here the sample is solid. We can dissolve it in a suitable solvent and the solution is to be injected. But before entering into the column, we must be converted it into the vaporized state. So sample injection system, it is actually used to inject the sample. It can be done with the help of syringe and the outer covering is made up of silicon rubber. Then moving to the column. Actually, in the column, the different components get separated by their interaction with the column packing. In GC, there are two different type of columns can be used. First one is packed column and second one is capillary column. Here packed column, which is made up of stainless steel, nickel, glass materials, etc. The inner diameter may be varied from 1.6 to 9.5 millimeter and the length is often 3 meter. Then we are moving to the capillary column. Actually, this capillary column is fabricated from the capillary tube and the inner surface is covered with the help of liquid stationary phase. So column, actually in the column, the components which is to be separated, how it is separated? By their interaction with the column packing. Here in GC, two type of columns can be used. Which are they? Packed column and capillary column. The speciality of each one I already mentioned. Packed column, it is made up of stainless steel, nickel, etc. Inner diameter may be vary from 1.6 to 9.5 millimeter and the length is 3 meter. Here in capillary column, it is actually fabricated from the capillary tube. At the same time, the inner surface of this capillary column is covered by liquid stationary phase. Then we are moving to the fourth category. Fourth part of the instrumentation of GC is stationary phase. There are two types of stationary phase can be used. Solid stationary phase and liquid stationary phase. If the stationary phase is solid, the technique is called GSC. If it is liquid, the technique is called GLC. In GLC, the liquid stationary phase must possess these three characteristics. First one, it is chemically inert in nature. Second one, it must have high thermal stability. And third one, it is having low volatility. So listen here once again. Three important characteristics of liquid stationary phases are chemically inert in nature. Second one, it possesses high thermal stability. And third one, it must have low volatility. Then the fifth part of the instrumentation of GC, which is detectors. So based on the physical property, there are three different types of detectors can be used, or there are different types of detectors can be used in GC. That's all about the instrumentation of GC. 5 different parts are there. Which are they? Carrier gas, sample injection system, column, stationary phase and detectors. But based on physical properties, there are different types of detectors can be used.